All right, so we're gonna finish our notes on 8-3. Here's example 3. Let's talk through it again. Grab my pens out. Okay, so here's what we did. The picture's not going to be drawn for you. I happen to have drawn the picture for you. And you had another question on last night's or Friday night's homework with a ladder leaning against something, right? This just happened to be a ladder leaning against a building. A ladder could lean against a tree. I don't know, what else would you lean a ladder against? A water tank. I mean, it could be anything, right? Anything that it could lean against. So I drew a building here. They told you the ladder was 16 feet, so I knew that if that's your ladder, then that measurement had to be 16 feet. Then they're going to describe to you either this acute angle or this acute angle. If they describe this acute angle to you, it's going to be the ladder, the angle that the ladder makes with the ground. If they describe this acute angle up here, it'll be the angle that the ladder makes with the building or whatever it is that the ladder is leaning against. Anytime you have something vertical and the ground, a tree, a flagpole, a building, a light pole, anything that's vertical will always be considered perpendicular to the ground, whether or not in reality it is, right? We will consider that it truly is perpendicular. And so your right angle you should assume is always there. When you draw these pictures, make sure that you're creating a right angle within your picture. And so that's why I drew this one for you. And then the question said, if this is a 55-degree angle and you have a 16-foot ladder, how far up the building, so this would have to be our X or unknown, could the ladder reach or would the ladder reach? Then you have to look at the angle that they've given you. If this is 55 degrees, I know I can find this angle over here just by subtracting it from 90, right? There's no need to do that unless you're dying to. I'm going to consider this my angle of reference. If you change your angle of reference to this one, because we could find it, it changes which trig function you use, whether it's sine, cosine, or tangent. So bear that in mind. If you change your angle of reference, you have to change whether you're using sine, cosine, or tangent. This one will use a different function than this angle. So we assumed that this was the angle of reference, and I only had two sides for that angle of reference. This is the leg opposite, and this was the hypotenuse. So we noted those. Anytime, and I'm going to write this, go ahead and write it, I guess up here. You need to be looking at toa. Remember, if you don't know how to spell it, how did I teach you to spell it? Some old hippie caught another hippie tripping on acid. Woo! Right? So, if I've got opposite and hypotenuse, you are purely looking at, these are your ratios right here to sine, cosine, and tangent. So opposite and hypotenuse is O and H. In this case, wouldn't I know to choose sine? You will always, 100% of the time, set up an equation that looks like this. You're either going to choose sine, cosine, or tangent. You can choose one of those three. You may or may not know the degree of your angle of reference. Sometimes that's a variable, sometimes it's an actual number. And then it's going to equal the ratio, something over something. This is your ratio right here. It's either going to be opposite over hypotenuse, opposite over adjacent leg, or adjacent leg over hypotenuse. It's going to be one of those three. How do you know which three? It depends on which one of these three you chose. How do you know which one of those three? It's based upon what you identified over here. Since we identified that it was opposite and hypotenuse, we chose sine. So that's why I wrote all this out. You won't always write all this out, but we did for our note purposes. So we chose sine. We knew the degrees was 55. And then we knew that we had opposite over hypotenuse. You won't always write this down either. So I put the x, which was your opposite, and the 16, which was your hypotenuse. I rewrote the equation here because this is what you truly should write each time. This is what we did for our notes. This is what I want to see you writing each time. There should be sine, cosine, or tangent here. This is either a variable or a number. And then you have two things here. It could be a variable and a number, or two numbers. It just happened that our variable was in the ratio. If your variable is in your ratio, you will make this into a proportion and cross multiply and solve. So when we cross multiplied, we got x here, and we got 16 times the sine of 55 degrees. Didn't we use our chart? And we looked up 55 degrees underneath the sine column, and we chose 0.8192. And we replaced sine of 55 degrees with 0.8192. And then use your calculator, multiply these two together, and we got 13.12 feet. We rounded to 2 decimal places. So therefore the ladder goes 13.12 feet up the building. Okay? I'm going to look at example 4 with you and see if we have something slightly different. All right, so let's go ahead and plot the points that they have given us. A is 2, 3. So here's point A. And B is 7, 3. So here's B. And then C is 6, 5. So here's C. And if I connect my dots, I should have a triangle. Now, did they tell us where the right angle is? Can you make a good, reasonable guess as to where it is? Which one appears to be right? A, B, or C? C. So if I were you, I would mark my right angle here. And if you want to really double check, how could you tell? Yeah, find the slope of AC by stair-stepping it. Find the slope of CB by stair-stepping it. And shouldn't they be opposite signs? Positive, negative, and reciprocals of each other. So if you're at all in any doubt, do that. This is definitely acute, isn't it? And isn't that definitely acute? So I'm betting that that's my right angle. And it's important to note where that right angle is. The question says, find the measure of angle A. Do I know that measure? Since I don't know it, what am I going to assign it? X. So this is X, and I know it's degrees. And it says I can use sine, cosine, or tangent. Have they given me any information on my side lengths? Yes or no? No. Is there at least one side that's easy to find? AB. I can definitely just count squares to find AB. So let's go ahead and count. 1, 2, 3, 4, 5. So this has a measurement of 5. Don't I need at least one more side in order to use sine, cosine, tangent? I can't have two variables. So what am I going to do? Use a distance formula. You decide whether you want it to be BC or AC. It really doesn't matter. As a class, let's go ahead and decide, what do you want it to be? AC? Does it matter? Not really. Let's do AC. So A here is 2, 3, and C is 6, 5. So I'm going to assign them values of x sub 1, y sub 1, x sub 2, y sub 2. And then my step 1 is going to be use the distance formula. From here on out, you will be allowed to use the Ames reference sheets on all tests. Because on my quizzes, you get to use your notes. It's your job to have your own Ames reference sheet on the quizzes. I will not give you one for the quizzes because you should have your own, but I will for the test. So if you don't know the distance formula by this point, can't you find it on your Ames reference sheet? Right? So if you don't know it, look it up. But here it is. And then plug in what you know and solve. Will somebody let our late person in?
Hi, it's from the Teacher Academy and Statistics.
Can you guys come back towards the end of class and I'll be ready for you?
Sure.
Okay, thank you. do not lose your square root sign. So here I have the square root of 20. As far as I'm concerned, you could decide to simplify that or not. Since you're not actually finding that side length and saying, well, the length of side AC is, I don't see any reason why you have to simplify it. So if I were you, I would leave it as the square root of 20. So now I have two sides and an angle that I'm trying to find. Is anybody unclear as to how I found the square root of 20? Are we okay with that? Okay. So then, if this is my angle of reference, right here, that's my angle of reference, is the 5 my leg opposite, my leg adjacent, or the hypotenuse? Okay, it is adjacent, but is it a leg adjacent? Isn't it directly across from the right angle? So it's the hypotenuse. So be really careful when you're identifying the hypotenuse that you don't call it the adjacent leg. So that means that square root of 20 isn't that the adjacent leg, right? Sine, cosine, or tangent has AH. All the way back up to here, sine, cosine, or tangent. I would be writing this on any test or quiz I had. Which one is AH? Cosine, right? So we're going to use this general formula for an equation. We're choosing cosine. Do I know my degree? Nope, so I'm going to put x degrees. And then I'm going to put adjacent over hypotenuse here. So we're going to write it. So then step 2 is to write your equation to solve. And so we've got, was that the door again? No. So we've got cosine of x degrees is equal to, if I do adjacent over hypotenuse, that means I have to do square root of 20 over 5. Well, that's supposed to be a degrees. Now, this is a little bit of a change. Anytime that you know the full ratio, remember on the opposite side yesterday here, when I knew this ratio, I could take the fraction and I could divide it out and find the 4-digit decimal. What did we do with that to find the degree of angle A? Remember? Looked in your table backwards, didn't we? Bless you. So here we are not going to turn this into proportion. The only time we turn this equation into proportion is if your variables are in the ratio. So we're going to get our handy dandy calculator and we're going to figure out what is the square root of 20 over 5. And so remember, your on button is down here at the lower left, so turn it on. If there's anything in the screen, clear it out. So if there's anything there, hit the clear button right here. It's on the right hand side underneath these cursor buttons. So make sure you have a blank screen. Then to find your square root button, it's right here above the x squared. So to get to it, you have to hit the second function key, and then you have to hit the square root. So you're going to hit second function, square root, and immediately your calculator gives you a little bitty square root sign and a parentheses. You have to end the parentheses. So you're going to put in the square root of 20. You must end those parentheses with the parentheses, and the parentheses are right here above the white number keys. If you don't, you're going to get the wrong answer. Then hit divided by 5. Anybody not find something? Are we okay? And then hit enters for equals. Question? You okay? All right, then hit enters for equals and round this to 4 places. It's 0.894 and it stays a 4. So make squiggly equal signs. So squiggly equal sign 0.8944. So we're going to look this up, and you might want to put in your notes, look up in table backwards. And then I'm going to show you after today how to use your calculator properly if you didn't have a table. But I'm making you do this because on the Ames test you will not have a calculator. You will only have a small portion of the table, and you need to know how to use the table. quite frankly. All right, so we're going to take our table, and because it's cosine, we're going to look in the middle column for something close to 8944. So here we get 4s, 5s, 6s. On the first part here we got 8, 9. So here's 8, 9, 10, 8, 9, 8, 8. Wouldn't it be in between these two? And be really careful because sometimes the columns go up north and sometimes they go up going south, down. You have to pay attention depending upon which side of the chart you're on and whether you're sine, cosine, or tangent. So if it's in between these two numbers, isn't your degree in between 26 and 27 degrees? And what did I say to put? 26.5. No matter what the book says, you're just going to go 0.5. So x degrees is approximately equal to 26.5 degrees. And so that was your job. That's what you're to find. Now, what I would like to do is go over some questions from yesterday's homework. So if you have a question, I want you to ask it. And I'm going to do a few of those up here. So you've got about, 10, 15 minutes of question time. So take out last night's. If you need to go grab a book, you can quietly go get one back there at the bookshelf. Do I? Which one? 47. So 47 was one of the more challenging problems. And 47 looks like this. There should not be any talking. Getting what you need should not require talking. So you got two variables in this one and two different triangles. Now this looks like one of our geometric mean triangles, doesn't it? Isn't it a big right triangle with an altitude run through it? The problem is we don't know our full hypotenuse. So, if this is my degree of reference right here, we're going to work with the big outside triangle first, because if I look at this angle belongs to this little triangle here, or the big triangle here. Because on this little triangle I have two unknowns, I don't want to work with a small triangle. On the big triangle, don't I only have one unknown? So I'm going to work with a big triangle first. So here, I'm going to identify 24. Is it the leg opposite, the leg adjacent, or the hypotenuse to that angle of reference? Opposite, adjacent, or hypotenuse? Opposite. And what's the x? Adjacent. So, ka, toa. O and A. Is that sine, cosine, or tangent? I'm going to write on a little piece of paper so I don't have to keep writing it each and every time the following. This is your guide all the time. Some old hippie caught another hippie tripping on acid. So you're looking at these last two here for OA. Which is it? Tangent. So I know I'm using tangent. So remember, you're choosing either sine, cosine, or tangent based upon which of these three you have. We're in this case going to choose tangent. You're going to have some degrees, whether it's x or a number, equals something over something. And remember again, this is the last two here, opposite over adjacent in this case. So that's the equation we're going to set up. So we're going to take the tangent. I know my degrees is 32 degrees equals opposite over adjacent. So opposite is 24, adjacent is x. Because my variable is in my ratio, I am going to turn this into a proportion, and I'm going to cross multiply and solve. This time, my x, and you have not had this before as far as notes though. Your x is in the denominator, so look what happens. You end up with 1 times 24 is 24. Whoops, I didn't mean to put that in red. Equals x times the tangent of 32 degrees. Don't I want to get x by itself? What's happening to x and tangent of 32 degrees? It's being multiplied, so don't we divide it? So those cancel. So x is equal to 24 divided by, then look up in your table, 32 degrees, which is right here. Find your tangent, which is 6249. I'm going to replace that with 6249.6249. Then you're going to take your handy dandy calculator, and we are using squiggly equals because we just abbreviated the tangent of 32 degrees because that's an abbreviation. Again, if there's anything in that window, clear it. And we're going to take 24 divided by 0.6249 equals, or enter. So x is a side length. We will round to 2 decimals for a side length, 4 decimals for sine, cosine, tangent, 2 for anything else. And we get 38 point what? 41, right? And I don't know what unit of measure this is. I'm just going to say units, whatever it is. So I know x. Now that I know x, 38.41, can't I use it to find y? Now you have a couple of options. You could use Pythagoras. Well, no, I wouldn't even use Pythagoras theorem because y isn't the whole distance here. So we're going to use sine, cosine, or tangent again, but on the small triangle this time. So according to same angle of reference, according to this, is this still the side adjacent? Where's my right angle on the small triangle? Where's my right angle? Right here. So what does that make this side? Now this is the hypotenuse, right? It's changed, hasn't it? Even though your angle of reference stayed the same, the triangle itself changed. So now what's y? Is it leg adjacent or leg opposite? Because that's all that's left. This is adjacent. So back to SOHCAHTOA. What's H and A, or A and H? A and H is cosine. So I know I'm choosing cosine, and I'm going to create this equation. So I've got cosine. I know my degree is 32 degrees, and cosine is adjacent over hypotenuse, caught another hippie. So adjacent is y, and hypotenuse is 38.41. Because my variable is in the ratio, I will cross multiply, turn this into a proportion. So 1 times y is y, and then 38.41 times the cosine of 32 degrees. Cosine of 32 degrees is different, so we have to look it up in the table, right? So look up 32 degrees again. Here it is, but cosine is the middle column. So this time we're putting in 0.8480. So replace it with 0.8480 and use your handy dandy calculator to multiply. This time we get 52.5. What does it round to? Stay as 7 or bump up? Stays as 7. So 52.57.
It's very
Oh, sorry, 32. Okay. Now, if you're off a few hundredths from the answer in the book, that's okay, because you're using the table of values. They might be using the calculator, and the calculator uses the full decimal, which you don't know yet. So if you're off a couple of hundredths, that's okay. If I see this and you're off a little bit from mine, I'll check your work and see why with a calculator and see maybe what you're doing. If I don't see the work, I don't know what you did, hard for me to give you full credit. All right, what else can I help you with? What other problems? Which one? 20? All right, so question 20. Question 20 deals with this picture. And I'm not going to redraw the picture. I don't like this picture. Can you tell me why? What's a problem with this picture in your book? Oh, it's a little fuzzy. There we go. What's a problem with that picture? And Mackenzie chose B because on this little triangle, it's super tiny, isn't it? Right? That's the problem I have with this. It's such a super teeny weeny tiny picture. It's hard to see what is what. So they want you to find in number 20 the sine of x. Oh, sorry. I was looking at 23. So the sine of x deals with this triangle here. So I take that back. We're looking at the big triangle, right? So you can have to ignore all this, but I do know that this side is 5, this side is 25, and this is 5 rad 26. You have to choose what sides go with sine. So because it's sine, sine is some old hippie, right? So I'm looking for side opposite over the hypotenuse. If this is my degree of reference, what side on this triangle is the side opposite? What side is side opposite x? 25. So this is my side opposite. What's my hypotenuse? It's across a right angle, so this is your hypotenuse. I. And so the sine of x is equal to 25 over 5 rad 26. Now the direction said find the ratio as a fraction and as a decimal. As a fraction, can't I reduce the 5 and the 25? They're both outside the radical. So 5 goes in here once and 5 goes in here 5 times. Can you have a radical in the denominator? So you have to rationalize, right? So you're going to multiply top and bottom by rad 26 over rad 26. So we end up with a final answer of 5 radical 26 all over a rad times itself is just 26. So there's the fraction. And then if we put that on the calculator, so then if we put the calculator up here, you're going to take 5. You have to use the second function key, remember, to get to the square root. So second function key, hit the x squared to get to that radical, and then we want 26. You have to end the parentheses, and then you can hit divided by 26. And so the decimal equivalency is 0.9806. Okay, what else? Only 2 questions. I find that hard to believe. T? 18? So 18 says the cosine of x. So same picture, right? So here's my degree of reference, but cosine has caught another hippie. So this time I'm looking at adjacent and a hypotenuse. What's the leg adjacent to x? It's the 5. So this is my adjacent. It's hard to read on that one, but it's actually the 5. And then my hypotenuse is still this. So the cosine of x is equal to 5 over 5 rad 26. And we have kind of that same situation. Divide the 5's out, but we also have to rationalize. And so I end up with radical 26 over 26, and then you'll plug that in the calculator to find your decimal. Remember, when on these calculators, you have to end the parentheses after you do square root of 26, and the parentheses, and then hit divided by 26. What else? There had to be more. This tells me that you didn't do your homework. That's what it tells me. And or you didn't grade it. Which one? 49. So 49 is another challenging problem. And so your picture looks like this. Do I have everything correct in the picture? I don't think I'm missing anything. Am I? Okay. So I really have two right triangles here. I've got the whole big right triangle, and I have this little right triangle here. I'm told that these are equal. So if I find this side, I can cut it in half, and that's what this side will be, right? So they want me to find x degrees and y degrees. As I look at the whole big right triangle, don't I have two sides to the whole big right triangle? I'm going to start with the big right triangle. I'm going to start with this being my angle of reference. So I can find this side and then cut in half, and then I'll have this side, and then I'll be able to find this one. So here we go. If that's my angle of reference, what is the 18? Is the 18 side opposite or leg opposite, leg adjacent, or the hypotenuse? Look for your right angle. So what's this one? It's opposite. So what's the 27? Hypotenuse. Which one is OH? Old hippie. Some old hippie, right? So we've got sine. So I know that we're doing sine. I don't know my degree. Is equal to, and I'm doing opposite over hypotenuse, so my opposite is 18. My hypotenuse is 27. So isn't this one where we're not going to turn this into proportion. If your variable is not here and you've got that full ratio, take your calculator and find that decimal equivalency. So we're going to divide it out. 18, divided by 27. 0.666, what? 7. So sine of x degrees is approximately equal to 0.6667. So I want you to look under the sine column. So your job is to figure out when do I look backwards in the table and when do I look forwards in the table. If you can come up with a ratio, you're looking backwards. So look under the sine column for 0.666 degrees. So here's where my sixes are down at the bottom. Here's 6.5, then it jumps up to 6.691. Isn't 0.6667 in between these two? So isn't x in between 41 and 42 degrees? So what did I tell you to say? 41.5. And so x degrees is approximately equal to 41.5 degrees. No, it's not. Oh yeah, x degrees. Interesting. All right, so we've got 41.5 here. How do I find this? Because I need this in order to find this triangle. What can I use to find this if I've got these two sides? Is that? I can use Pythagorean theorem. I could also use the 41.5, and I could use sine, cosine, or tangent over here too. It's your choice. I probably would use Pythagorean's theorem. Just because, what if you made a mistake there? Could you have made a mistake there? Sure. So let's use Pythagorean's theorem to find this. So we've got a squared plus b squared equals c squared. Is 18 going to be a, b, or c? Let's put it this way. What's 27 going to be? C. So this is gonna be C. So what are you gonna let this be? Can it be A or B? Does it matter? It doesn't matter. So I'm gonna let it be B. So we've got A squared plus 18 squared equals 27 squared. So isn't A squared equal to 27 squared minus 18 squared? And then don't we take the square root of the whole thing? Can't I put that in my calculator exactly as it shows? So here you go. Use your square root button. So square root of 27, just hit your squared button and look what happens. So it shows 27 is being squared. You're still underneath the radical because you haven't finished out the parentheses. Minus 18, hit the x squared button. Now you need to finish off your parentheses and hit enter. 20.1 what? 2. 20.12. So A is approximately equal to 20.12. And so if this whole distance is 20.12, what's half of that distance? Because this is half, these are equal, so this is half. What's this one? What's half of 20? 10. What's half of 12? So 0.06. Now, if this is my angle of reference right here, there's my right angle. What is the 10.06 to this angle of reference? Isn't this opposite? And what's the 18? What's the 18? It's leg adjacent. What is OA? On acid. What's OA? Trippin' on acid, right? Tangent. And so I know I've got tangent of y degrees is equal to opposite is 10.06 and adjacent is 18. So again, because I can find out what that ratio is, take your calculator, divide it out. 10.06 divided by 18. And you get 0.558. Eight what? It bumps up to 9, doesn't it? So look in your table backwards. So look under the tangent column for 5589. So you're over here on the left side. Here's 57, here's 55, and then 53. So wouldn't it be in between these two? So our tangent is what? 29.5, because it's in between. So y degrees is approximately 29.5 degrees. So that required a lot of work. What else? I'll do one, maybe two more, depending on when they come back. Yeah. Which one? 33? 43. Okay. So then, oh, we're choosing all the toughies. All right, so actually this one's not so bad. 43 is a typical one that you'll get. And they've drawn it this way. Is that 5.8 there? And is that 18 degrees? It's small, I can't read it in the dark. And then X. So, I have my angle of reference. Here's my angle of reference. This is my right angle, right? So what is 5.8? Is it the leg opposite, the leg adjacent, or the hypotenuse to this? Leg adjacent. So what's the X? Hypotenuse. So what is AH? Cosine. Caught another hippie, right? So we're using cosine. I know my degrees are 18. equals, if I do not see this equation, you will lose lots and lots of points. Because for some reason I have some kids that won't set up this equation. They get the right answer, but they don't set up an equation, and they kind of do it piecemeal. I need to see the equation. And so my adjacent is 5.8, my hypotenuse is x. Your variable is in the ratio, so you have to set up a proportion and cross multiply and solve. So this is the harder one that requires an extra step. So as I cross multiply, I get x times the cosine of 18 degrees equals 1 times 5.8 is 5.8. Then to find x, don't you divide both sides by cosine of 18 degrees? And you get x is approximately equal to, you need to replace the 5.8 with its equivalency. So find the cosine of 18 using your table. Cosine is the middle column. So here's 18 degrees. Cosine's the middle, so we're going to replace it with 0.9511. And then use your handy dandy calculator. Would you let them in? And we get 5.8 divided by 0.9511. Come on in. Just give me just 1 second.
Sure.
And so then we have 6 point, is it 09 or does it bump up to 10? It bumps up to 10, so it's 6.10. So x degrees is approximately equal to, I'm sorry, not x degrees. X is approximately equal to 6.10. All right, so your homework tonight is practice 8-3 and to finish your quiz review.